Welcome to the assignment overview, sines and cosines 4.05. In this lesson, we're going to talk about the sine and cosine ratios. Here, we're going to let angle A represent our theta. When we let angle A represent our theta, we can draw an arrow to the opposite side. The hypotenuse is always the longest side, and the adjacent is next to angle A. Notice that our right triangle has turned here. A is still going to be our theta, but notice that our opposite when we draw an arrow has changed, and it's now over here on this side. The hypotenuse is up on top, and the adjacent is on the bottom. The adjacent is always next to our theta, and the hypotenuse is always the longest line. The opposite never touches our theta. Let's let angle A represent our theta in this situation. This triangle is rotated in a unique way. For me, if I look at the 90-degree angle and then I go across from the 90-degree angle, I immediately notice that that's my hypotenuse. Now I can draw a line to the opposite side, and the only thing left is my adjacent. If sine 60 plus cosine 0 equals 90, what is theta? Well, in this case, we don't have any measurements, so maybe we should check our next slide because I think something's missing. Oh, good, something was definitely missing. Now we have some measurements in here. So let's review what we learned already to find the value of the hypotenuse. Since the given sides are opposite and hypotenuse, we're going to go ahead and use the sine ratio. We're going to set up our equation so that sine theta is equal to opposite over hypotenuse. Then we're going to cross multiply sine theta times hypotenuse equals opposite times 1 and solve for x. Let's go ahead and put in this information. Sine theta is 36 degrees. This is equal to the opposite, which is 14, and we don't know the hypotenuse, so I'm just going to go ahead and put in h. You could also put in x if you wanted to. Now I'm going to cross multiply, remembering that if I put a 1 under this, it's still the same information. So sine 36 times h is equal to 14 times 1. Now I can separate this so that I have sine times h is equal to 14 times 1, which is just 14. Now if I divide both sides by sine 36, I get sine 36 on this side is eliminated, and I have only h, and I can go ahead and divide sine 36. I can go ahead and divide 14 by sine 36. That tells me that the measure of the hypotenuse is 23.8182. If we'd like to, we could use a whiteboard to help us solve this equation, just so that you can understand how I did this. Notice that I have sine 36 is equal to the opposite, which was 14, divided by the hypotenuse. What I'm doing here is I'm setting up a multi-step equation. So I'm going to go ahead and cross multiply. This is going to give me sine 36 times x. My goal is to get x by itself. So when I multiply sine 36 times x and 14 times 1, I get sine 36. X is equal to 14. Now I'm going to divide both sides by sine 36. This is going to eliminate sine 36 on both sides, and or on top and bottom, and it's going to give me x. Now I can divide this side by sine 36 as well, and that's going to give me the value of x. We now know how to find the ratio, but what if we are looking for the other angle? What is the sum of all the angles of a triangle? So if I were to add 90 plus 36, what would C plus 90 plus 36 add up to? Yeah, absolutely, 180 degrees. Because remember, this is half of a rectangle. A triangle is just half of a rectangle, and a rectangle adds up to 360 degrees, or a quadrilateral adds up to 360 degrees. So half of that is 180. So now it's very easy for us to figure out the measure of the missing angle. We can use the equation 90 plus 36 plus C equals 180. By using my calculator, the first thing that I'm going to do is add 90 plus 36. I notice, I don't know if you can see that, but it comes out to 126. So then 126 plus C is equal to 180. Now, I'm going to go ahead and subtract 126 from both sides. That tells me that C is equal to 180 subtract 126. Again, you can't see that, but it's 54. Now, you probably already thought this in your head, but just in case you didn't, I did notice that sine and cosine will add up to 90 because the other measurement is always 90 degrees of a right triangle. So if that's the case, all I have to do is say 90 minus my other angle, which is 38.5. And that tells me the angle C is 51.5. So I can always use the equation of my given angle plus my missing angle is equal to 90 if we're talking about the two acute angles, because sine and cosine are always going to be acute. Now, we know that if sine is 61 degrees, cosine theta is going to be what? Well, let's set it up. The value of theta is going to be 90 minus 61. Therefore, cosine theta is equal to 29. Let's go ahead and do another one. What are the measurements of an acute angle of a right triangle such that sine x is equal to cosine 2x? The measurement of the acute angles in the right triangle are x and 2x. The sum of their measures equals 90. All right, so notice I have x plus 2x is equal to 90 degrees. Well, if I have 1x plus 2x, then that means I have 3x's is equal to 90 degrees. So that means then each of my x's is equal to, if I divide both by 3, then each of my x's is equal to 30. 30, 60, 90. Awesome. All right. So notice up here, sine is just 1x. So that means that sine is 30 degrees. And then cosine is equal to 2x's. Well, 1x is 30, so 2x is 60 degrees. And now I have solved sine x is equal to cosine 2x because they both equal 90 degrees. They're complementary angles. Here's a little bit of a challenge for you. Given sine x is equal to 0.6 and cosine x is equal to 0.8, what is tan x? Well, we can set it up so that tan x is equal to sine divided by cosine. So when we do that, we can say 0.6 divided by 0.8. Now, when we simplify this, we can go ahead and notice that 0.2 goes into both the numerator and the denominator. This is going to go ahead and give us 3/4. So tan x is equal to tan 3/4. For today in our information. But boy, was it fun. If you have any questions, please feel free to text me or call me.